This is the exciting final item on the student height spreadsheet, which you've already been through and filled in, where you've been deriving the best measure of variability and effectively deriving the standard deviation from these large data sets of student heights. But what you're able to also do is to predict the likelihood of there being a 7-foot tall student. The assumption behind this is that the standard deviation and the mean of the sample actually are the standard deviation and mean of the population. So we know that by knowing the standard deviation of the mean, then we can specify the particular distribution of variation away from the mean on the assumption that the distribution is a normal distribution. So we're assuming that the deviations away from the mean are normally distributed, and we've worked out the standard deviation and the mean, so that means we can plot the normal distribution of the expected population, and the normal distribution extends to infinity. The distribution doesn't actually cut the y-axis, it's asymptotic to the y-axis, so there could be a student well over 7 foot tall, but the probability of that is vanishingly small. So to make this clear then, let's actually do the calculation. So we've got the height classes here, and look, we've added a 2 meters 10 height class. It's not extended to 2 meters 10 because it's gone from 2 meters to 210, so we've just added the 7 meter class, and we need to then use our model of variations away from the mean, and our model is the normal distribution. And that's what we're going to write in here, the equation for the normal distribution. You can pick the equation for the normal distribution up from the normal tab. You've used it here when you're producing your own statistical table. So there's the equation, and it features the size of the population. In this case it's the unit normal distribution, and the size is 1. The mean, and the mean is B2, which is referred to there, and the standard deviation, which is B3, which is referred to twice. You need to remember that because we're going to copy this formula into the other spreadsheet. So let's copy it. Paste it in, and then if we click on there, we'll see we're still referring to B1 and B3, but we're on a different spreadsheet now, so we need to change these numbers to make them appropriate. Remember, this B1 was the size of the sample, which in the previous spreadsheet was 1 because it was the unit standard, the unit normal distribution. But here, the size of our sample is 500, so that's 500. Then we need to replace B3 is the standard deviation, and we're taking the standard deviation from year 2000, so we can click on that. We need to also make sure that we've got an absolute reference to it because we're going to copy it down, so we need to make sure there's a $sign in front of the 10, which we can do by pressing F4 repeatedly or just putting a $sign in front of the 10. So similarly, B3 is the standard deviation, $sign in front of the 10, and then B2 is the average. Click on the average, and again we need to make an absolute reference to it, so make it $6. Okay, so that is almost all that we need to do. Let's see. Click that, and we've got a frequency. It's quite a low frequency. When I copy it down, we should see that the frequencies increase around the mean, so they're low a long way away from the mean. They're symmetrical about the mean. There's the graph that's been plotted up of it. This cell here is the sum of all those frequencies. The sum of all those frequencies. And it's coming to 99, or effectively to 100. That's not right because our sample size is 500, not 100. So there's something we need to do here, and it's because our height classes go up in 5s rather than in 1s. They go up in 5s, so we need to multiply each of these frequencies that fit for a size class. We need to multiply them by 5. Multiply that by 5, and we can copy that down, and there you go. The sum is now equal to 500. Not quite 500, because the area under the curve would extend beyond 2 meters 10 and below 1 meter 50. It doesn't ever cut the axis, it's asymptotic. But anyway, we've got here the class that's the 210 centimeter class. If we divide that frequency by the number in the sample, we get the proportion of students that are greater, well, that are in the 7-foot size class. You see there, so our frequency divided by 500 and then multiplied by 100 because we've been asked to quote it as a percent. There you go, it's a very, very small number, 2.88 e to the minus 9. You could change the 210 to 400 and find the frequency of 400 to 405 centimetre tall students in just the same way.